So the first step is, in the lab is importing Pandas library as PD. Then we are going to, load the file using the read CSV function, and we load the data into the data frame. Okay, it's about marks. Now it's possible that you have many data frames in a single program. For example, one about students, one about teachers, one about courses, let's say. Okay, so they will be different data frames, and that's why we will give it a name like df marks, df teacher, and df let's say courses, etc. So that will help us in understanding what each of the variables is about. Okay, so the head function will show us the first three rows. Now here we see that some values are NaN, which means that they are empty or null values. Okay, so for example, this student, he or she did not take, or return the homeworks and so on. Okay, she just returned until the midterm. So anything after the midterm was not for that student. Maybe she dropped the course after the midterm. Okay, so this is the head. Similarly, I want to see the last rows. Okay, so this will show me the last row. So overall I have 56. Now one thing I was telling you is that CSV can have other options as well. Okay, so this is the path of the file, but I can give additional information. For example, what I see here is that I have one row, one column which is 0 1 2, and one column which is 1 2 3, and similarly here. Okay, so actually in the file which I have added here, there was already a number, a serial number, which is this. And when you load a file, Pandas adds its own serial number. Okay, so what I can do is that I don't need two. Okay, so this one is enough. The number column is enough for me to act as a serial number of a student. Okay, so I can say that IND. Okay, then I press the tab button. Okay, so when I press tab, it will complete for me automatically. So index column, what is my index column? My index column, it is an O. Okay, so NO will become my index column. Now I press again Control Enter to execute that, and this time the difference will be that when I execute it with Control Enter, so you see that my index has become this one. There is no additional column. Okay, this column has become my index as well. Okay, which is good because I don't need an extra column. I already have the serial numbers. So I see in the tail also that I have this thing. Okay, now if I want to see how many nulls are there, for example, let's say, so I can print this, and I see that true means that there are nulls, and I can see that there are many trues throughout. Okay, similarly the opposite of this is not null. Okay, when I want to run this, I can see that this is not null. True and false means that this is null actually. Okay, so this is the opposite. So true and false, these are different values. Okay, D types, if you remember, what does that mean? That you can see that the question, quiz 1, quiz 2, all of these marks, they are type float except for the ID. The ID is what you can see. The ID is, if I go up, ID is this. So this is taken as integer, and the rest they are taken as float, primarily because when you have NaN, so the Panda, it assumes that this is a float point, so it will automatically consider that as a float. So we see that all these types have been considered as float, which is fine. Okay, but actually we don't need them to be as float. Why? Because if you see here the info and the describe functions. Okay, we already know about this. So mostly actually the numbers will be 3 and 4, something like this. Okay, like they will be integer numbers. And similarly in the info, if you remember, we did last time. Okay, so we have integer numbers. What I want, okay, is that I convert these floats into integers. I don't want floating numbers, I want integers. Okay, so the question 1 will become integer and so on for all these things until the end. So I have a function, okay, to convert like quiz 1 into type of integer because I like integer. Okay, so I need integer actually. It's not about liking, but maybe I don't need float, I will say. Okay, I don't need float, I need integer. Okay, so I will convert that into integer using this thing as type. Okay, so I will explain this, just bear with me. What I want here, understand this. Okay, what's happening? I say that the Q1 column of DF marks. Okay, this is the Q1 column of DX mark. If I just execute this, what will happen? Okay, let's see. If I say DF, okay, marks, sorry, what I'm doing. Okay, DF underscore marks, and then Q1. Okay, if I execute this, it will give me the complete column, just Q1 column. And you can see that there are 4 marks, 2 marks, 3 marks. Okay, then there are some NaN, but all of them, they are integer. Okay, there is no 3.5, 3.3, something like this in general. And that's why I prefer that I convert this column as type integer. When I convert this as type integer, so that will be actually giving me just 4 and 3, something like this. Okay, so I want to convert this into integer. And how do I convert that? I will take this column, and there is a method which is known as type. Okay, as type means that convert this type, the type of this column, to what? Integer. I say type what? Type integer. So when I apply this function, okay, it will give me the type of the column as integer, and I assign it again to Q1. So overall, this line is doing is that converting the type of Q1, which you see here is float, okay, to type of what? To type of integer. Okay, but there is one thing, because you see here, if you make a conversion, so there are some NaN values. Okay, we have seen that there are some NaN. So NaN is actually not a number, and we cannot convert that to integer. So what we need to do is that if we have any NaN, we will convert that NaN into 0. Okay, so this is one function which says that in the df marks data frame, all those NaN, okay, if there is any NaN, we will fill that with 0. Okay, so what will happen? Let me just cut this and let me make it into a separate one here. Okay, before this. So what I see here, if that I do apply this, okay, I will change the df such that every NA number will be replaced by a 0. So if I press that and then I print it, okay, by using this, it will print me, and you can see it has printed to me what? With no NaN. Now everywhere there was NaN, it has been converted to 0. Do you understand this point? I hope it's clear that this command, it converted the NaN or the null values to 0. Okay, so now we don't see any null values. All we see are zeros if the value is not there. Okay, so that's an easy way to convert. Okay, similarly, you see before, okay, before Q1, here you can see the 15 and 16, they were NaN. Okay, now I try again, and you will see that 15 and 16, they are 0 now. Okay, because I converted, okay, here I executed this command to convert it into 0. Okay, so if you have any question, you can ask me, otherwise I'm continuing. So now my data is float, but there is no NaN. Okay, what I can do now is convert each of these, okay, because I applied fill NA to the whole, data set, the whole table or data frame. So I can convert now one by one into integer. Now remember, I did this as one by one, although there is, easy way to do that using for loop. But I'm not using any for loop here. Okay, I just want to show you that one by one I'm using all those columns. So there are 11 columns. Okay, 4 plus 4 plus 3, those 11 columns, I'm converting all of them to integer. Okay, I hope you understand this thing. Okay, so I control enter. Okay, and then once again I check the d types. Before, the d types, when I checked here above, you can see it was, the first one was int 64, and then the remaining, they were float. Okay, and now let me do it once again. Okay, here, and you can see now all those are int 64. I can do better, let's say, if I convert them into int 32. Okay, what's int 64 and 32? Well, 64-bit and 32-bit. Now 32-bit integers, they can contain values up to 32 bits, okay, 2 power 32. And normally in the students, table, okay, 32 bits are enough. Okay, you don't need 64 bits in general. Okay, but fine, it's int, it means that's fine. we will use integer 64. So the first step, what we did, okay, step by step I will explain. We loaded the data, okay, using the read CSV. Then we displayed the data using the head and tail, and we found that actually it contains some null values, NaN. Also, I needed to convert that to integer because they were as a float type. So first what I did was I filled the not null values, okay, by 0 using the fill NA method. Okay, now I used 0, but you can, let's say if you want, you can fill it by some other number. Naturally 0 is the best number. Okay, if you want to fill with some other number, you can do that, but that will not be actually logical. So logically a null number means, let's say, something not available, or you can safely replace it by 0 in most cases. If I make it 10, okay, so it will replace all the null values by 10. Not now, because now there is no null value, but let's say in the beginning when there were null values, if I use the same function and I write here 10, so they will all be 10, but that would not be logical. 10 is not a logical number. 0 is something logical, which means that if it's not available, okay, the student has not taken the test and the student got 0 marks, which is fine. Okay, so after converting all those into integer, let me run this once again to see. Okay, Q1, and you can see now these are integers. There is no 0.0. Okay, so 4 and 4 and 4, before it was 4.0, 3.0, something like this. So now I'm sure that all my data types are integer. And if let's say I describe once again, okay, here let's say, so although this one, you see, it is still using float. The reason is that it is doing some operations which converts these numbers into floats. Okay, so although here you see floating numbers, not integers, but that's fine. Okay, similarly here, now you see before it was float 64. Now I do info again, control enter. Okay, it has been converted into integer. Remember that I executed this before. Okay, I can do, the good thing about using this notebook, okay, which I'm using online, is that you can do something here to check, then you can do some other operations. When you come back and check again, it will be changed. Okay, so before you see, if you see in the recording, that before they were not 57. Okay, there were some different values. Why? Because there were some null values. Okay, now all of them are 57. What does it mean? That they are now what? All of them, they are non-null. All of them, they are 57 are non-null in ID. Q1 has 57 non-nulls and so on. So it means that there is no null now. Okay, all of them have some value. Okay, then there is a length function, okay, which shows me the length of the data frame, which means how many records are there, which are 57, as we can see also from here. Okay, the shape function we used last time, which shows the how many rows and how many columns. So 57 rows and 12 columns. Okay, I can just find one. If I do this, it will give me 12, which is the number of columns, or if I do 0, this will be the number of rows. Okay, so I can use that thing to find exactly how many rows or how many columns are there. Okay, then there is a function size. What is size? It is the total number of cells in there. Okay, which means that the shape 0 multiplied by shape 1, or the number of rows multiplied by number of columns, which is exactly how many data points we have. So this is 684. Okay, okay, what are the columns with us? Okay, so if I see here, these are the names of the columns. So columns, okay, dfmarks dot columns, it gives me the total columns that I have. Okay, similarly by columns I get the total columns. If I say column 0 or columns 1, what happens? Okay, so column 0 is what? This is my column 0. Okay, this will be my column 1. So for this one, it will give me ID. For this one, it will give me this quiz 1. Okay, any idea what will be -1? What is meant by -1? Okay, just give me a minute. Last, excellent. Last, this is last column. Okay, let me explain this using another code. Okay, So let's say I have that names is equal to, let's say, apple, fruit names, let's say fruit name, apple, banana, okay, orange, then I have mango, and I have grapes. Okay, so when I use this, it means I'm creating a list. Okay, this means I'm creating a list. So if I want to print, I will say print names. So it's just going to print this as a list. This is a list of items. Okay, now if I want to just print the first, what is the first item in this list, I will say print names 0. Okay, so it has printed me to me apple. Okay, then I can say print so 0, it starts with 0. This apple is 0, banana is 1, orange is 2, mango is 3, and grapes is 4. Okay, so if I have 4, it should give me grapes. Okay, so there are 5 items, but because it starts with 0, so we are, yes, we are just getting what the last one as n minus 1. So n items, n minus 1 will give us the last item. Okay, that's clear. Now I can also use, okay, the same way as minus 1. Okay, so yes, minus 1 will be what? Minus 1 is the same thing as the last item. So last item is grapes once again. If I say minus 2, it means what? Second from the last. So minus 1 is grapes, second from the last is mango. Okay, so that will give me, oh, right, that will give me mango. Minus 3 will give me orange. Minus 4 will give me this, and minus 5 will give me apple, for example. Okay, so I am starting the reverse way. Okay, now I also have an operator which is known as the range operator, or the colon operator. It means that I select more than one. Okay, so if I give it 2, what does that mean? It means that start, let me do it like this, from 0 to 2. It means start from 2 of position 0 and just go until position 2, but do not include 2. Excellent, Najul, thank you. Okay, so it will just give me 0 and 1. So 0 will be apple and 1 will be banana. It is not giving me 2. Remember, 0 to 2 means it will give me, yes, all elements before 2, starting from 0. Okay, so apple and banana. Okay, and if I say 0 to 3, it will give me apple, banana, and orange. Okay, similarly, if I start from 1 to 3, it will give me element number 1 and element number 2. Element number 1 is banana, and element number 2 is orange. Okay, this is done. Yes, any question?
Print name is 2, 3. Just print bananas and bananas. Just
1 to 3 is banana and orange. Okay, so this is 0, this is 1, this is 2. So 1 to 3
to
means
the
I will have
bananas and
1
orange.
and 2, which is banana and orange. Yeah, thank you. Okay, so I have to that. If I want these two, what should I do? I just want mango and grapes. Yeah, 3 to 4. So 3 to 4, do you think it will work? Let's see. 3 to 4. Well, it's giving me only mango. 3 to 5. Let's try. Okay, 3 to 5. Yes. Okay, although there is no index 5, but you see 3 to 5. Okay, then okay, -1 to -2. Okay, Asma, give me another solution. Okay, we will see that also, because I can start from last. Okay, so one option is if I do this. One student gave me this answer from -1 to -2. That is empty. Why is this empty? Because you are counting from here to here, and you are counting the opposite. If I do this, what about this? -2 to -1. Okay, so again, this is -2 to -1 because we are not including -1. So it will only give me -2, which is this one. What I can do, even I can ignore this. or I can put 0. Let's say -2 to 0 means what? Okay, -2 to 0 means there is nothing, because 0 is actually this one. Okay, this one is 0. So I want to do from -2 until the end. Okay, so I want to do from -2 until the end, which is mango and grapes. Or the other way was, if I do it from, this is 0, 1, 2, so from 3 to 5. Okay, so there are different ways of doing the same operation in this. Okay, what if I do 3? Let's the same thing. Okay, so I will start from 3 until the end. So if I don't give the last index, it means until the end. Thank you. And I can also do, because I don't give the index. So what does that mean? Can anyone tell me? What will that do? So it will start from 0 and before 3. Okay, it will go until before 3. So that means 0, 1, and 2, which means apple, banana, and orange. Okay, so this is how it works. Now you understand this is how you select items. So similarly, what I want to do is apply the same thing. I know my columns. These are my columns. Okay, so this is list of columns. So 0 is ID, 1 is Q1, -1 is project, which I did this. So this will print me project. From start to 2, what does that mean? It means 0 and 1. So this will print ID and Q1. And here, the last 5, from -5 until the end. So what are the last 5? It should start from H2, right? From H2, H3, H4, final term, and project. Let's check that. Okay. Oh, sorry. No, no. I was wrong about this one. Actually, you have to start from start and go until ignoring the last 5. Okay, you will not include the last 5. So this is the last 5. Okay, you will do from start until this position, which means from ID until H1. Okay, so one way is that this, and the other way, I was thinking, actually I didn't note the operation, I was thinking about this. Okay, so you see what happens is that this one did the first all those rows but ignoring the last 5, and this is going to start from the last 5 until the end. Okay, so you can see that we get these items. Okay, is there any question? No. Okay, excellent. Okay, so we know about columns, how to select columns, etc. Why do we need these columns? Because we may need to select some column from, this is the name of the column, okay, but we can need some operations that column number 5, I need column number 5. So how do you do column number 5? So the idea is, why do I need this? Let's say that I say df underscore marks, okay, for example, and I select what I will say df underscore marks, okay, dot columns, for example 5, let's say. Okay, now this is 1. Okay, df dot columns 5, it will give me column number 5, which is 0, 1, 2, 3, 4, 5, which is midterm. Okay, so it will become, actually this will become same thing like this. Okay, so df marks midterm, it gives me only the midterm marks, and if I do this, you see it gives me the midterm marks. Okay, so it depends that if I don't use the names, I can just refer to by the list like 0, 1, 2, 3, and so on. Okay, so we understand now the role of columns. Then there is the index. Is the index, you see that the indexes, they start from 1 until 57. Okay, why is that? Because these are the numbers you can see. Okay, so this number is the index, which starts from 1, which goes until 57. There are a total of 57 students. Okay, the name of the index is no, which is the number. Okay, and the type of the index is int64. Okay, then we know about the mean. What is df marks? Okay, df marks is the whole data frame, and I want to find the mean, so I will press enter, and you can see this is the mean for ID, then mean for quiz 1, etc. Okay, so it means that for each column I find the mean. Similarly, df what if I do one more thing? If I write df axis is equal to 0, mean x is equal to 0. Just see what happens. See these numbers, 4, then 2, then 3 something, okay? Okay, it gives me the same thing. Okay, what if I now make it 1? X is equal to 1, so that has changed. Why? What's that actually? X is equal to 0 and x is equal to 1. Now, in the table, actually, we have two x's. Here, if I go back to the table, okay, x is 0 means the index wise. Okay, so when I say x is 0, it means this row wise. Okay, and when I say column x is equal to 1, so this means apply to this column. So when I say mean and x is equal to 0, it means the mean or the average of the whole column. So at the end there will be the average of this column, then this column, and then this column. When I say x is equal to 1, so it will give me the average of whole row. So the average of this row, or the mean of this row, then the mean of this row, and so on. Okay, so you can see what is the average of this row. So all of them are 0. Total there are how many? There are 11 columns. Okay, and if I sum this is 4 plus 3, 7, 8, 9, 10, 11. 11 and 10, this is 21.5. Now 21.5 divided by 7, this is going to be 3 point something. Okay, so on axis is equal to 1, my first, this student, okay, who has number 1, okay, the average will be 3 point something. And if I do see here, okay, where was that? Okay, it was, yeah, so 3 point something, for example, let's say. Okay, that was the average of the student on x is equal to 1. Okay, but the problem is, sorry, there is one problem, that because I have included, they are all the same. Why? Okay, this is 3 point something plus power 6, so this is more than that. The reason is this includes the id also. Okay, and I will show you what's the problem here and how we can solve this problem. Just wait a bit. Okay, so this is not the good thing to do. This is not the good thing to do. It creates a problem. And the problem, okay, let me clarify. The problem is that it is considering this also in the average, but this is not the average. It is also considering this. I want the average to be only for these numbers. Okay, these numbers. Okay, so I need to specify that I need to start from Q1 until the project, not including all. Okay, now I go down, and then with basic statistics, so we know about the mean. Okay, what is dxmarks.count? Let's see. Okay, so there are 57 items in id, 57 in q1, etc. Okay, if they were some null numbers, then it will not be all 57. It will be different. But because I removed all the null numbers, I replaced them by 0, so I get 57, which is actually fine. Okay, now there is marks.sum. Okay, dfmarks.sum, and if I sum it, I get the same problem. You see that the ID, because you see the ID of a student is 430, something like this. Okay, so it has summed all the IDs. Like one column of IDs you get at the end, then one column of quizzes you get at the end, 153, 154. So this is all the columns, and sum is at the down. Okay, if I say here x is equal to 0, once again it will be the same answer. Okay, it will give me the same answer because it's going to be the column wise sum, or which means the sum of each column. Okay, so that is x is equal to 0. Next, if I change it to x is equal to 1, so this is row wise sum. And the problem is, once again, you can see this is mainly the IDs, because it is including IDs in the sum. So the sum of the course will be around 100 marks, for example. And if you add it to ID, it will become something like this, which is not good. So we need to remove the IDs. Okay, this is an important thing. We need to remove the ID and the number from the sum. We don't want, ID and the number to come. Okay, we don't want these two columns, the number and the ID column, to be in the sum. We only want this. Okay, and we already said that for this student this is 21.5. Okay, so it should give us 21.5, not this very big number. Okay, so how should we do this? There is a method which is called drop. Okay, drop means remove those. Remove what? Number and ID. Okay, I don't want number and ID. Okay, remove them from df marks. And x is equal to 1 means remove those columns. Okay, so number and ID, they are in the columns. That's why I say x is equal to 1. If I don't write x is equal to 1, by default it will become x is equal to 0, which means rows. But in rows I don't have number and id. Number and id, they are in the columns, so I say x is equal to 1. Okay, so at this step I will have a new thing. What does that mean? Let me copy and check it again. Okay, what happens? So we know that if I apply this, okay, then I will, oh sorry, what is that? df.drop, what does it say? No, not found in the axis. Okay, why not found? Let's check it. Okay, so how can I check it? I will just comment this. If I say df marks, I use this, so there is id and number. Okay, so number is actually index, it cannot drop the number. Okay, so it can only drop the id, because number is not the, you see, number is index, so it is on this side, so index can never be dropped, only these columns can be dropped. Okay, this command was actually before, when I did not read the number. So because now number is my index, so we will remove the number. Okay, so what happens is now that I will say that just drop the id. Okay, drop the id, which means this one. So how will it look like? It will look like as this. Now you can see these are only the marks without the id. Now if I apply sum to this, okay, so now if I apply dot sum and x is equal to 1, what will happen? Okay, now remember one thing, yeah, one more thing is that when I use this function, it does not change the data frame. Okay, it makes a copy. What does it mean is that I say drop id, but if I print it again, okay, so it will contain id. Okay, so the drop id works only for this statement. If I try again, the id will be available. If I want to draw it permanently, I will tell you what to do. Okay, but we don't want to drop it permanently, because this is the idea of the student, we need it. So that's why I will just say drop id. Okay, so it will give me a new data frame without the id, and then on the new data frame I will apply the sum x is equal to 1. Okay, so that will actually give me only the sum. So you remember it was 21.5, so it gave me 21. That's fine. Okay, because the 0.5 was removed. Okay, we converted into integers, so anything after the point was removed. So 21.5, it became 20. And the problem here is that you can see the total marks, okay, but this is the sum, but we don't know what is that exactly. Okay, so we need to do some way to actually say that this is the sum. Okay, so now this is the same thing as I did in the last thing, and in both this we now actually don't need to do the id. Okay, so I execute it again, and this is giving me the same result. Okay, now there is one more operation or property of df or data frame, which is the iloc, which means index location. Okay, why do I say index location? Because you see here in 20, okay, this is 0, for example. Okay, marks 20 is 0. So if I say index location 20, okay, so what was 0? Actually, that was what? Okay, wait. What did we do? Let's see. Okay, without, if I say, because I applied that to the whole. Okay, wait. So you see, this is my, df marks. Okay, so this is my number 1. Okay, if I say df.iloc number 0. Now here is one confusion. Okay, that's interesting. I will explain it to you. This function iloc 0, it means index location 0. Okay, if I execute it, it gives me for the first student. Remember, 330 is the first student. Okay, 330 was the first student, you can see. Okay, so index location 0 means that because this is index location 0, then index location 1, and so on. Okay, now I want to need just the location 1. Okay, at this location, this is not index, the location 1, so I will use this. Okay, so iloc 1, it is giving me that 330. So there is a small difference between iloc and loc. Okay, in this case, when I say lock, and if I make a copy, Control C and C and V, and I use wait, iLock one. One is lock one, the other one is the iLock one. So what's the difference between the two? Okay, you can see the lock one, location one, gives me this, and the iLock one gives me different. Okay, one is 460, one is 330. This is actually, you know, the first student, okay, by the location one, this one, and this is also the index, but not the first location, because my index starts with 0. So this is, you know, you need to understand this. Currently, the problem with this, it's not a problem, but here, because the numbers are 1, 2, 3, so it's not clear. In general, we might have indices in which there are not 1, 2, 3. There will be different number. For example, I can say that my ID is this. Let's see. Okay, what I can do. Okay, to make it understand further, let's do one more thing. Let me do a trick. Okay, I will say that df underscore marks dot set index. Okay, what was that? ID. Okay, if I do this, now ID will become my index. Okay, now in this case, if I say iLock 0, so this will be my iLock 0. And if I say lock 0, it will give me error. In fact, here also, lock 0 will not work. In this case, you know, before what I used, where is that? Log 0 will not work. Why? Because there is no 0. My IDs start with 1. My numbers start with 1. So log 0 will give me error, but iLog 0 will give me this. I'm not sure if I'm clear on that, or I could explain it very well, but I hope that you can practice with it, the difference between iLock and lock. Okay, so once again, let me see what's in my df underscore marks, okay, dot head, and let's say I want to see just the first row. Okay, you can see it has not changed the index, although here I changed the index. But why it didn't change? Because it is a copy, as I explained to you before. If I want to make it permanent, I will do it like this: df underscore marks is equal to. If I did this, then that will become permanent. My new copy will be exactly the same thing. But let's say I don't want this right now. Okay, let's say, or maybe let's say I want it. Okay, I want to make it permanent, for example. Okay, so if I press enter, okay, and now once again, because now the change is permanent, if I do the head, so the ID should be the index and there should be no number. Okay, and you have seen that. Now it is permanent. Now my ID is there. Now if I do this, it will be clear. df underscore marks, okay, dot iLock 0. What does that mean? Index location 0. So index location 0 is the first record, okay, which contains 4322, which is this thing. This is the first location, or index location 0. But if I say lock 0, well, this is an error because there is no 0 here. The location will be some ID. So let's say I want to find this ID, okay, 29. So I copy this, okay, and I will say give me this location which has this value, and it will, oh, wait, why? Key error 436. Okay, just let me check. I don't know. Oh, strange. That's strange for me. Just give me, is it complete or not? Wait, 43607170. Okay, 436071. Where was that? 4360 and 7170. Well, wait, let's check. Okay, okay, just I'm confused myself. Okay, wait. This should work because what is the index? Let me check the index. Dot index. Okay, this is the index. Okay, the index is this. So from this index, I will select the location. of the first one, which is, let's say, 435083330. Okay. Okay, that's going fine. So what was the error? Okay, let me check again. What was the problem? Index. Okay, so this is my index. And let me check this one. Okay, I don't know why it gave me a problem. Okay, I copy this and I paste it here. Okay, I made some mistake maybe in copying pasting. Maybe you have noticed that maybe the number was incorrect. I made some mistake. Okay, so if I have a random number, let's say I make it 8, which may not be there, so that will give me an error. So that number was not there actually. I made some mistake in typing the number. Okay, so this number was there, and you can see it gave me the values for that index. Okay, all the values for this student ID. Okay, these are the quiz 1 marks, quiz 2 marks. Okay, do you have any question? Because I'm going to the next part. Okay, okay, there might be definitely some confusion, but you know that we are recording this lecture, so you can ask, you can see this later to clarify. And I hope that you are also trying to do these steps with me. Okay, last time I reminded you, but today I forgot to remind you that you have to do this with me to actually, you know, being able to complete this. Okay, so iLoc will be index location, which will start from 0 until n minus 1. Okay, so 57, and n minus 1 means 56 will be the last one. Okay, if I try to do 57, so at 57 there is nothing because there are total of 0 to 56. Okay, and loc means I need to provide an index number. Okay, so 436, whatever it is, I will give that number and it will give me, you know, the rest of the data for that number. Okay, now if I say that iLoc, okay, and iLoc, let's say 1. Okay, so index location 1 is this thing. Now index location 1, but I want, let's say, midterm. You can see the midterm is 15. Okay, let me try if this works or not. Midterm. Okay, what does it mean? Well, it gave me 15. How does it work? Let's do it again. What I have is that index location at 1 has this data. Okay, and this data itself has, you know, these, you know, the indexes. Okay, so I can say that from this data, give me H4. So it will give me, you know, this 8. Now why I don't do this here and why I don't do this here? Can anyone explain to me? Okay, why I use this as a string and why not this as a string? Okay, let me give the answer. Because these are actually strings, they are not numbers. I mean the names, they are strings. Okay, Q1 is not a number, Q is not a number. So that's why we know that it is a string. Okay, and 1, 2, 3, okay, 1, 2, 3, here we know that it is of type integer. Here we know from here that these are of type integer. So this is integer. Okay, and usually you know the index number because we say index location, so this will always be an integer. Okay, the log can be, you know, here for example you see that I have the ID. If you see, the ID is the index. Now this is a number, but I can have like the country name or the city name as an index, in which case I can use in the log function here, I can use the name of city. For example, I can say Taif if my location was Taif, but because my location here is, you can see, you know, these IDs, so they give me an error. It will only work if I give the correct look, you know, index 436. What was the number? Let me check. The thing is, iLoc will be a value from 0 to 56. Okay, so iLoc 1 means the second record. Okay, the second record, and H4 means I want only, for example, the homework 4 marks. Similarly, I can say the project marks for the student and it will give that to me. Okay, similarly, instead of writing the string, I can give it an index value. Okay, So when I say like the student number at location 20 and 0, so you know 0 is this. Okay, what is this? This is the quiz 1 marks. Okay, then 1 is what? 1 is quiz 2 marks, I think. If I say from 1 to 5, they will give me 4 values. Okay, quiz 2, quiz 3, quiz 4, and midterm. And if I say starting from 5 until the end, it will give me the last 5, starting from 5 until the end, okay, whatever they were. Okay, so this is how I select these ranges for one student. Okay, similarly, okay, if I want to have a sum, what does it do? Can anyone explain this one? Let me do it for 0, so we know, because for 0 we know what was that. Yeah, what would that be? Do it like this for easy thing. Okay, yes, what's that? First, let me make it clear what we have. Okay, dot ilog 0. Okay, this is ilog 0. And then I say ilog 0 dot sum. What will it give to me? It's difficult to control this. Okay. Any idea? df marks underscore ilog 0, it gives me this. Okay, so for the first student, it gives me all his marks in the quizzes, in the homeworks, midterm, final project, final term, and the project. Okay, this is what I have. What will this do? Sum all values. Okay, so it will be 4 plus 3 plus 2, and we already know that this is equal to 21. Okay, we did this before. If I want to see the marks in the quizzes only, so I will select quizzes first. Okay, so how do I select quizzes? I will select the first 4 columns. Okay, which means like this, right? It should be like this. No, well, wait. Okay. 0, 1, 2, 3, 4. Okay, so from 0 to 4, actually these are, again, the student has only this. I included the midterm. I should not include the midterm. So I should do until 4. 0, 1, 2, and 3. Okay, that gives me 11. 4 plus 3 plus 2 plus 2. That is 11. Okay. If I want for homework, of course, the homework are all 0. Now let me check, let's say for student 1. Okay, so student 1 has these marks in the homework. So homework is 1, what? 0, 1, 2, 3, 4. So homework is from 5, 6, 7, 8. From 5 to 9, it should be this. Okay, so for student 1, from 5 to 9, which means that it will be H1, H2, H3, and H4. And if I sum that, it is 33. Do we have this to be equal to 33? 10 plus 9 is 19. 19 plus 6 is 25. 25 plus 8 is 33. So this is actually giving me the sum of homeworks. Now this is not the good way, because I have to see every time what is at 5, what is at 9. Okay, but we have other ways which we are going to see. Okay, so if we want, like here I say that I have df underscore marks. Now I don't have the total. I want to find the total for each student here. What should I do? I need a new column. Okay, so there should be a new column total, which should contain the sum of all of these for each student. So for the first student, it should be 21. For the second student, it should be something, and so on. Okay, so I want to create a total column. How do I create a total column? I will use the name of the data frame and then the name of the column I want. Okay, so it doesn't exist, it will create a column. I say that total will be equal to what? The total will be equal to, you drop the ID and the number, and we know that the number is already dropped. In fact, the ID will also give an error. Why? Because the ID is already an index. But let's see. Okay, let's see. We cannot drop ID. So df marks dot drop ID. Okay, and dot sum x is equal to 1. What will happen? See, ID should not be dropped because it's not in axis, it is in index. Okay, so I will say df marks is equal to df marks dot sum axis is equal to 1. So it will sum all these numbers from q1 to project, and there will be a new column for this student. It will have the marks in this row, for this student in this row, and so on. Okay, I don't need to drop anything because the only thing I have is an index, and it does not add index. Okay, it will only add the non-index columns which are in the axis. Okay, so I want to have sum on axis is equal to 1, which means I want to add the columns, the data from the column for each student, and then I will try to print it or display it. Okay, so you can see now that I have a total column new. Before there was no total, there was until the project. Now I created a total column. How did I do this? I used the sum method. Okay, and it gave me the sum of the whole axis on the column wise. Okay, and the result was there in the total. Okay, I hope you understand how did we create a total automatically using just this command. Okay, and that's very important command. Okay, similarly, instead of total, in addition to total, I can have a mean. So here I will say mean, the average of the student, and I will create a new column mean. Remember this, so that I don't put mean in the total. I will also change this to mean, and I will also change this to mean. Okay, similarly I can have max, okay, or min, let's say. Okay, and there are some other ones like standard deviation and variance, etc. I can create over here, but variance is of course for the whole data, and standard deviation, so no, I could not, for each column it will be the same value, but the sum is applied to individual rows. Okay, okay, there is one more, that is the apply function. Why do I need apply function? You see there is one problem. The total marks, they are greater than 100, which is not good. Okay, so 2199, they are good. Okay, but for some reason, let's say for some students I have more than 100 marks. Okay, why is it that? Well, whatever the reason is that, but let's see. I know that students marks, total marks, cannot be greater than 100. So what I want that in this total, if there are any marks which are greater than 100, so I will make it 200. I repeat, I will check the total. Okay, if there are any marks which are less than or equal to 100, then it is okay. But if it is not less than or equal to 100, then I will make it 100. Okay, so what I want to say is that if total is less than or equal to 100, then it will remain same total. Otherwise it will become 100. Okay, you understand my point. So I will have an if condition in programming. If this mark is less than or equal to 100, then it's the same mark, else it will become 100. So this will be changed to 100, this will be changed to 100, it will remain 33, it will remain 81. Okay, only marks which are more than 100, they will be changed to 100. So the apply function is a function which we apply to the whole data frame or to a column. So here I choose one column, which is the total, and I say apply the function. What function I want to apply? Okay, now because I want to apply this to a column, so this function will take a value from here. So when we are considering the first student, the value will be 21. Then for the second student, it will be 99, and so on. Okay, so this will check one by one for all the values, okay, in this column. Now apply means check all the values, and I will give the name total, for example. Okay, so for the first student the total was 21, for the second student the total will be 99, and so on. Okay, so here what does it say is that I define a variable total. Okay, and it will be what? It will be the same total if my value of the variable is less than or equal to 100. What I want to say is that for each student I will have some variable. Okay, this variable will be actually from this column. It will be the same total if my total is less than or equal to 100. Otherwise it will be 100. Do you understand this or not? This is a little bit syntax. Okay, maybe it's a little bit problem, but actually this is, you know, the way. Okay, good. If you understand, excellent. I'm very happy. Okay, so I repeat, we will take this column. There will be 57 values, and we will apply a function to this column. Okay, and this function means that we will apply it to every value. Every value means that it will start from 21, 99, and so on, one by one. Okay, it will apply to 57. So each value will be considered as a total. We just name it a variable. You can call it, for example, some other mark. Okay, mark or m, let's say, or m or m. Okay, so if my m is less than or equal to 100, then I will consider the same if. Else, my m will become 100. That's what it wants to say. Okay, so the output will be what? It will be same m if m is less than or equal to 100. Otherwise, the output will be 100. Okay, so either this condition is true, the marks is less than or equal to 100, or this is not true, then I will set it to be 100. Okay, so this variable is not important. It can be any name. Okay, but it should be the same, m, total, 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 or whatever you call it. Okay, so what will be the outcome of this? The input is total, and the output, I put it in a new thing, which I will call it total 2, for example, or total new, or whatever. Okay, so I will say that in total 2, you have the same marks from total, except that if marks is not less than 100, then we will make it 100. So let me execute, and then you will see the result. Now I have a new column, total 2, and you see that if the marks is less than or equal to 100, it's the same, 21, 21, 99, 92. But whenever it is more than 100, in this case, it will be replaced by 100. 106 is 100. Okay, 101 become 100. 106 become 100, and so on. So the maximum marks now you can see is 100. Okay, and I can also check this. How can I check this? Okay, let's see. I want to make sure whether it's true or not. So you know that df marks, okay, total dot max, and I don't specify any axis, so the axis is 0, which means it will be applied to all the rows. So the max in total is 127, okay, which was before, and the new one is total 2, so the max is 100. There is no value more than 100. And if I want to see the min, I think the min is 21, the same student, or maybe there is for total, what was the minimum? It was 0. Okay, so there was one student who had 0, and there is also total 2, which was 0. I don't know who was the student, but yes, this student, you can see she dropped in the start of the semester, so everything is 0. Okay, so I hope you understand the total and total 2. Now I don't need, you know, total now. Okay, what I want is that I will, okay, yeah, okay. Let's see, I hope, inshallah. Okay, so what I want is that this total is now useless for me. I want this to be my total. Okay, the true total should be this one, because it does not contain any errors. So I will drop this total, which means I will remove, and this one will become my total, new total. Okay, so I need to drop. We already know about drop, so it will be removed, and I will rename this. So there is a function which is drop, and there is a function which is rename. Okay, so let's see this, but before that, before doing this, I define a function. Now you know about function in programming. In, you know, C, C++, you say that void main void, or for example there is some function which returns integer, or which takes as input some integer, etc. Okay, we define a function very simply in Python. So the name of the function is grade. It will take some input like marks, okay, and def means that this is a function. So we define a function with the keyword def, then we give the name of the function and what will be the input of the function. And within the function, what I'm doing, I'm checking that if marks, which is this input, if they are greater than 95, then it will return A plus, which means that it will say that this student has A plus. If the marks is greater than 90, then this student will be A, okay, greater than or equal to 90, and so on. So I define all the possible grades. Greater than or equal to 60, D plus, sorry, a D, okay. And if none of these conditions is true, which means that it is less than 60, then it will return F. I hope you understand functions. Is there any question in here, this thing? Do you understand this, the function? Okay, good. So I repeat that I define a function. The name of the function is grade. It will take as input marks, and it will return me the grade of the student. So let's say if I have something like 78, okay, so 78, this is false, this is false, you know, this one, this is false, 78, this is false, this one will be true, so it will return me 70 C plus. Okay, similarly for 68 it will return to me D plus, and any marks less than 60 it will return always F to me. Okay, so here I check this, I say print grade 91. So grade 91 means the grade function will take the number 91, it will return something. So 91 is what? It should print A. 61 is what? It should print D. And 44 is what? This should print F. Okay, because 44 means the student is failed. So, okay, I did not execute this actually, sorry. So let me execute this first. Okay, it is there, now it is defined, and then I will execute this. So you see, this is what they print. Okay, now you understand the the purpose of grade. It will take as input some marks, and it will return the grade of the student according to the marks. Very simple. Now why do I do this? Because I want that here I add a grade column. So there will be a grade, and for this student it will return F, for this student it will return F plus, sorry, A plus, this will be A, then this will be B, and this is F, and so on. Okay, so it should be like this. So how do I do this? Well, I will use the same apply function, but remember what were the columns. You see, we have the total column and the total 2 column, and I don't want, you know, to be this. I want this to be the total, and I want this one to be dropped. So how do I drop and rename the columns? First I drop it, okay, df marks that drop, and x is equal to 1 because I want to drop a column. Now here you see I want to make it permanent, so I assign it to a new df. Okay, it's the same variable, I assign it, which means that after dropping, the new copy will have you know, no total column. And then after that, what I do, or let me do it so that you can understand. Okay, I remove this, I will create a new one. Okay, df, and then let me print the head. Okay, df marks not head, or even I don't need to print the head, I will print the columns. Okay, so previously df marks.columns, it contained total and total 2. Now I drop the total, and when I print it, okay, there is no total, the total has been removed. Now I will rename this to total 2, okay, which I do using the rename function, and this is the way. Okay, so this is known as a dictionary, which means that in this brackets, okay, these you know, what is they call the braces, okay, I define the first which I want to change, and I define the second as the value I want the new value to be. This is a dictionary. Okay, so this is known as a key. We will see that later in some other lecture, and this is a value. So I want that whenever there is total in this total 2, I change it to total. Okay, so this represents a dictionary. So this total 2 will be renamed to total. And once again, if I print the columns for the third time, I will see that the total 2 has been replaced by total. Okay, now if I just print, you know, I will print the head 5, let's say. Okay, so you see my total. Okay, and there should be no number greater than 100. Okay, let's move to the next point, and we are going towards the end, which is that I want a new column which will contain the grade. Okay, so for that, how do I create a new column? If you remember, how do we create the total column? We said that we have gave marks, and then we should put here the grade because we want to name it grade is equal to some, you know what, apply. Okay, we will apply function, and what do we apply? We want to use the grade function. Okay, the grade function will take the marks and it will return A plus or B plus. So how do we do this? Okay, how do we do this? We do this using this. What do we do? I create a new column, grade. Okay, but I create this from total. I apply the function on total. Okay, and in this function I say that the input is marks. Okay, and the output is what? Grade of marks. So the input will be 21. The output will be what? If you pass 21 here, it will give you F. If you pass 99 as marks, it will give you A plus, and so on. So here is my variable marks, which represent these values from total, because the column name is total. And I apply, you know, to the same variable the grade function. So it will give me the you know, grade for each student, and that will be a new column, grade. Let me execute that. Okay, and you see this now. Excellent, isn't it? Very easily I created the grades for all the students, and you can verify them that they are correct. I mean, there is nothing wrong. Okay, if there is any question you can ask me. Otherwise, what we did in the last two steps, at the first we created the total. Okay, in fact 3 steps. First we created the total from these, you know, existing columns. Then we set the total to a maximum of 100. We dropped the you know, extra column, and then the third step was we find the grades using a function. So before, you know, when we were using total in the function, here I just use the if condition. Okay, in the apply function. For calculating grades, I didn't use the if function. I gave the name of another function which contains some condition. So I can apply as, you know, complicated functions as here, and we will see in the course, inshallah, that there are many ways to do that. Okay, many other things which are possible here. Now I have the grades, etc. What I want to do is that, you know, these are random numbers. What if I sort them according to the values? So there is a function which is known as sort values, and it says by which column. If I want to sort it by the, you know, total, or I want to sort it by the homework or the midterm, and so on. Okay, so if I sort it by the total, you know, it will be sorted. Okay, here. But many students have 0, not just one. You can see 1, 2, 3, 4, 5, 6 students actually, they had 0. Okay, one student which had 6, and so on. But they are sorted in, you know, ascending order. This is known as ascending. The minimum is at the top and the maximum is at the end. Okay, so this is maximum. And grade wise, you can see the F1s, they are first, then you have D, and then you have C, C plus, B, B plus, and the A plus, they are at the end. So how can I sort it in the, you know, reverse direction, which means that the top or the maximum should be in the top and the minimum should be at the bottom. Okay, so there is an option for that. Remember this thing. Okay, the same thing, except that we will add an option here. Okay, and what is the option? We will say that make the ascending is equal to false. So here ascending is equal to true, which means that it is ascending order. When I say ascending is equal to false, it means descending is equal to true. So it will be descending. Descending means starting from the maximum until the minimum. So this is what I will see. Okay, so I did it using the total. Now I can also do it another way. I can, let's say, sort it by the final term, for example. Okay, so by final term, you can see that, you know, again, they are all A plus, which means that those students who got total 100, they were also good in the final term because they got 50 and 49 in the final term. Okay, so those students who got good marks in the final term, they also got good marks in the whole. So almost all those students, you can see that at the end, those students also got 0 in the final term, and so on. Okay, so final term is a good predictor. We say this is a good predictor for your final grade if you did well in the final term. What about the midterm? Let's see. Okay, I sorted by the midterm. While again, you see midterm, all the A students. Well, there is one student, interestingly, who got high marks, but because she dropped the course somehow, she got an F, because after the midterm, you see she was doing very good until here. But then later on, she dropped it for whatever reasons. So she was very good student, but she had some personal problems or whatever. So she dropped the course. Okay. So this is how we sort. You understand the sorting, okay? How do we sort it? Next, what's remaining? There is an interesting thing, another function which is known as group by. Okay, so maybe the students from mathematics and statistics, they understand it, and maybe the students of computer science, they have also used the group by function. So what is group by? We actually make groups or classes of some attribute. So here I say group by, and by is equal to grade, which means that I want to create groups of student using the grade. So how many possible grades are there? You can see I have A plus A, B plus B, etc. Okay, and after doing the group by, I want to count in each group. Okay, so this is how I use the group by. I specify I want the grouping by grade, and then I count them. Okay, so it will give me a very nice thing. Without group by, this is not possible. Okay, you remember, if I don't do group by, it will give me the complete count of everything, but with group by, it gave me the count of A's. I have 4 A's, I have 18 A plus, I have 6 B's, and so on. Okay, but you see this whole table is redundant. These things are repeated again and again. So what I can do is I will add this. Okay, before there was no grade. Now I say that from this group by, just choose one column, which is the grade. Okay, and when I do this, you can see that the grade is A plus, etc., and this is the count. Okay, so A has 4, A plus has 18 total number of students, and there are about 15 students who got F. Okay, so this is the group by, and group by has very advanced functions. It's very useful, and I would say an essential practice, but because it is a small data set, we will use it. Of course, I will give you a homework to test that, how to use group by. Okay. Okay, then there is one more thing, which is filtering. What is filtering? Okay, filtering means you put some condition to filter in or filter out something. You want some conditions. Okay, so here is one way to filter. I have the DF marks. Okay, and within this, I can even I think remove that. Okay, here I can remove that, no issues. Okay, what I want here is that within DF marks, I want what? I say give me all those DF marks for which the midterm is greater than 15. This is a syntax. You should understand this syntax. Okay, so give me DF marks such that those DF marks will have the midterm marks greater than 15. Okay, and if I enter this, you can see that these are only those students who have more than 15 midterm marks. Okay, so how many students are they? Let's say I want to say, so I will assign it a name, for example, mid 15. Let's say this is my name of variable, which will contain those students who have more than 15 marks. Then I will write mid. First, let me say let me see what is the length of mid underscore 15. Okay, how many are these students? And then I will print it. Okay, so okay, wait, yeah, I need to have print here, sorry. Print the length of the number of students who are in mid 15, which is 14. So 14 students have more than what? 15 marks in the midterm. And who are those students? What are the records? So I printed it here. Okay, so this is the midterm one condition. Okay, midterm marks is greater than 15. I can combine two conditions using the and if I want to use this, it's important to use the brackets. Okay, these parentheses. Okay, so with the parentheses, I have one condition in the parentheses and I have another condition in the parentheses. So now what I want is that give me all those students from the list of students who have more than 15 in the midterm and more than 40 in the final term. Okay, so if I execute this, I already see this actually. So you can see these are only A plus students. Well, actually, even the A plus students, they have more than 15 in the midterm, but before they were 14 students. Now let's see how many students are they. If I want to find it, I can just, if I want to find the length, I will just say give me the length. Okay, so I just enclose this in the length, and when I say there are only 7 students, so only 7 students, half of those students who have more than 15 and more than 40. Let me make it stricter. I want to find those students who are more than 45. Okay, let me make it stricter. I want to have this 17. Okay, so only 3 students who had more than 17 in the midterm and more than 45 in the final term. Okay, is there any student who has more than 17 in the midterm and less than 40? Sorry, what did I do? And less than 40 in the final term? Well, one student. Okay, she did not do well in the final term. Okay, but in the midterm she had 18 and she got A plus. Why? Because you see here she had very good marks in the homeworks, and out of all those quizzes she had very good marks. Okay, so that's why she was A plus. Otherwise, in the midterm, on the final term, she had less than 40. So this type of analysis you can do in the data frame, something greater, something less, and you can have as many and or are. There is also something are. Okay, this is are. So all those students who have greater than 17 in the midterm are less than 40. Now this will be a huge thing. Okay, let me make it opposite. Some student who has less than 17 or greater than 40. Well, let's see. Okay, so many students, of course. Okay, this is true for many students who have less than 17 in the midterm. You can see this is or less than 17 or more than 40 in the final term. Okay, so this condition is true. This is not necessarily true, and because this is or, so it means that this condition is true. Okay, this condition is true here. This condition is true. Okay, so any student who has more than 17, let's see here, any student who is 17 or more than 17, okay, here, and this is 42. Okay, it has A plus. Okay, yeah, greater than 40. Okay, so any type of combinations of different possibilities of searching for some patterns, you can do this. Okay, I can just have one condition. All those students who have more than, for example, let's say 95 marks. So I will have one condition. I will just delete this. Here I will say total, and here I will put it as greater than 95. So that will give me only those students who have more than 95, and so on. Okay, now we are not taking break. We are just finishing this. Then we will stop for some time. Okay, we will discuss. So visualization is the final part, I believe. What is visualization? You use graphs and plots, charts. Okay, so what I want here is that plot of final term and midterm. Okay, let me enter that. Okay, what do you see here? Well, this is very strange. Okay, this is not something good. This is not something legible. Why? Okay, let me wait. Just let me. Okay, sorry, I don't know why. Because it says ID here. It's not midterm and final term. Well, strange. Okay, I don't know why it says ID. X label is equal to ID Y. Let me try again. I don't know why. Oh, it's taking ID. Strange. Okay. Um, okay, let me do it like this. Just plot the final term. Let's say. Okay. Why is it taking ID? So it's always considering ID on the x-axis. Okay, there must be a way to do that. Okay, but for the time being, I'm unable to do that. Why does it choose ID with this? Okay, yeah, this is index. I understand it is, but I want it to do without index. You are totally right, this is index, but I thought that it would do without the index. Okay, yeah, it's index, so you're right, without index, how can I do it? Okay, so it's doing, this one is doing with index. Let's try the next one. Okay, the total. Okay, so I have total, I plot, but I find a histogram. I need to find a histogram. Okay, what is a histogram? Let's see that. Okay, so a histogram is using frequency, okay, for different, you know, here we say that there are different bins. So how many bins it has created? You can see the bins are that the first bin is from 0 to 10. So 7 students who have less than 10 marks. Then from 10 to 20, there are about, you know, 2 students who are between this 10 and 20. Okay, then there are 1 students between each of you know, 30 and 40 and 50. Okay, so I hope you understand the number of bins. So it is taking like 10 numbers, so which means that it is creating 10 bins. So we can see from here that the students between 90 and 100, how many students they are? About 22 students. Okay, so default is 10 bins. If I want to make it, let's say bin is equal to 5, I want to have these divisions as 5 bins, which means that one bin will be between 0 and 20, the next bin will be 20 and 40, and so on. Okay, so let me see this, and you can see that between 0 and 20 there are 10 or 9 students. Okay, and I can also confirm this using, you know, here. Okay, what I, how can I confirm? I will say the total is less than 20. Okay, so if I give this condition, okay, so these are the total number of students, and I can use the length function to find how many students are there. So there are 9. Okay, so 9 students, they have less than 20 total marks, and using this I have seen that yes, less than 10 students or 9 students, they have less than 20. So between 20 and 40 there are about 2 students, and so on. Okay, so this is visualization, or a way to see, you know, graphically or visually, that most of the students they are here. Okay, and minimum number of students here. Okay, one more type of plot is about the scatter plot. Okay, and here I specify what I want on x-axis and what I want on my y-axis. So I want to see the correlation between midterm and final term. Let's see first, and then we will discuss. So what you see here is the midterm marks are from 0 to maximum of this, which is I think 19. Okay, so the students have marks from 0 to 19. Okay, and in the final term, okay, we have marks from 0 to 50. So few students they have 50, you know, 2 students they have 50. One has I think 49.5 or maybe 49, and then 48, and so on. So these on the y-axis I have final term and midterm. Now what this show, okay, this shows as, you know, this is known as a linear, sort of linear relation. Okay, so it is increasing. So as the midterm marks are increasing, the final marks are also increasing. Okay, these students, they had, like, you know, they are up on the final term, which means that they had very little marks in the midterm. Okay, but they worked very hard in the, well, not actually, but in the midterm, like say this student, in the midterm she had 5.5 or 6. Okay, and in the final 25, for example. Okay, so she did better in the final term. Okay, so this tells us about, you know, some visualization that this student performed very well in the final term as compared to the midterm, and so on. Okay, uh, these two students, they did well in the midterm. They had more than 50% mark. Okay, but in the final term they did not do well. They had 11 and 12 marks, so they were poor students in the final, and so on. Okay, this was about visualization. Okay, then there is one function which is known as dir. Okay, dir. What is dir? It means directory or the list. So these are the possible things in the, you know, df marks you can do. Okay, many number of functions: cumulative max, cumulative min, covariance, count, we have used some. Then there is the correlation. We are going to use it, the correlation. Okay, eval equal mean max. Okay, median, sample. Okay, sample is also interesting. What is sample? Okay, I want to see a sample. Okay, so df underscore marks dot sample. Okay, I want one sample, which means random, some number. Okay, some record randomly. So it gave me this one. I execute it again, so this gives me a random sample. I want 5 random samples. Okay, so random students. Some students are A, some are B, some are F. I execute it again, so it gives me a sample of different students. Why do we need this? Because sometimes you may, in experiments, in statistical experiments, in data science, you want to take some sample or random data. Okay, so you can actually assign this to something. For example, my sample. Okay, this is my sample, and sample is equal to this, and after that I can do anything with the sample. Okay, so for example, I can say that sample dot max, for example, let's say just okay, so it will give me that in quiz 1 the sample had maximum of 4, in quiz 2 the sample has maximum of 5, and so on. Okay, so sometimes we may need the sample method, which I just find here. So there is a rename which we have used, rename axis. Okay, we can use that. There is a skew in statistics. The size we have used, the shape function we have set, we have used it today. Set index, we used it today, and there are many more. Okay, but you can see that most of them we have already used. There is also the resample. Okay, sampling is taking a sample. Resample means shuffle. Okay, there is also the shuffle. So see the difference between the. I think there is also the shuffle. uh, no, there is no shuffle. So this is resample. Okay, resample, I believe it will do the shuffling, so it will rearrange in a different order. Okay, the default order will change. Where is interesting, we will see that in SQL you have some condition, okay, to check for something. There is transpose. You know about transpose in a matrix. Okay, what is transpose in Arabic? I forgot. But transpose, you change all the rows to columns, okay, and all the columns to row, for example. Okay, so df marks dot I say transpose. Okay, so wait, transpose, yeah. Okay, so you can see that all the IDs are now in columns, and on rows we have the thing. Okay, matrix, yeah, transpose of a matrix. You have studied that in matrix. So we have changed the rows and the columns. Okay. Okay, values, we already know what is values. So if you see the values, it means only the data without the the index and without the column names. Okay, so these are the values for the first student. Okay, these are the values for the second student. Okay, so just values sometimes you need. Okay, so for example, values, I'm not sure if it will work or not, but let's see. Okay, oh, it doesn't work for values. Okay, because values is an array, sorry, a list actually. Okay, we can see that it gives me an array, so we cannot apply that way. We have different ways to do that. Okay, then D types, we already know that D types are the integer 64. What is the type of DF mark? So it is a data frame. Okay, and we already know how to choose one column. Let's say I want to choose only mid. Okay, midterm, so it will be there, and the type of midterm is a sequence, sorry, series. Okay, series is what? It is a set of numbers. Okay, just one column. So if you see now, this is a series, so it has the index the same, and it has these marks. So remember, the index is the ID, so we use the same ID. If the index was different, so we'll see that like 0, 1, 2 or something like that. Now this is interesting that I have the ID and the mid. Okay, similarly, instead of mid, I can choose some other thing, final term. So I will see the ID and the final term. This is known as a series in which you have only one column with the index. Okay, value counts. Okay, so you see that in the midterm, because I applied to the midterm. So 13 marks were 8 students who took 13 marks, 8 students who got 0, 7 students who got 17, and so on. Okay. Similarly, let's say I apply this to the same thing, that grades. Okay. So df underscore marks, and what were that? They were grades. Okay, and grades dot value counts. So I already did that. Okay, what is that? Grade, it's grade, sorry, not grades. Okay, remember these types of problem. So a plus 18, we did this before using, I'm not sure, value count or something like that. We saw that before also. Okay, similarly for one more column, like for quiz 1, if you want to find the mid and the max, and yeah, and unique. Okay, how many unique numbers are there in the quiz 2, for example? Okay, so possible unique numbers are 5. What are the unique numbers? I want to see the unique numbers are 0, 2, 3, 4, 5. So I think no student took like number 1. Okay, so they took either 0 and either 2, 3, or 4. So there was no student who took 1 mark. Okay, similarly, I saw how can we set the index to the ID, which is already there. I have done this. Okay, and in the cities I can choose one student, like this 28. Okay, so okay, 28 is not working. You know why? Because my index numbers are like these. So let me choose this thing. Okay, instead of 28 I will say that what is the mid for this student who has this ID. Okay, and it gives me 0 because he had 0 marks, for example. Okay, I convert something to list. Why? Because in the list, okay, if I see the list, so the midterm marks now they are in the form of a list. Okay, so I can do something very steps operations. For example, I can search if 13 is in the mid list. Okay, 13 was there. Okay, if I can search if some student had 9, for example, yes. Okay, if I can see if some student has 1, let's say, so no student had 1 in this list. Okay, 0 was there, 13 was there, and so on. Did any student take 20 after 20? Okay, in the midterm, no student took 20. I think the maximum was 19 or 18. Okay, yes, so maximum was 19 is there. Okay, final thing about correlation. You know about correlation? What is a correlation?
It's like a measure of central tendency, uh,
Mm-hmm.
like the relationship between two variables.
Mm-hmm.
If we
So
have two
what are the
samples,
possible values? What are the possible values of correlation? What it can be?
zero,
Let's
zero,
say
one,
I have.
minus one.
Mhm.
It's a
Sorry.
range. It's a range from -1 to 1, +1.
Okay, and what does that mean? If the correlation between two variables is -1, what will happen? If it is 1,
-1,
what will
it's
happen?
mean
If it is 0?
it's
Mm-hmm.
decrease or it's decreases.
Mm-hmm.
Uh,
If one increases, the other one
it's
decreases.
strong but
Okay, one
decrease.
is okay, so they
And
are
if
opposite
one
to each
is
other.
zero,
Okay, so
yes.
if one thing increases, the other thing will decrease. That is -1 or negative correlation.
Mhm.
One means that
One
if
means
one
in
increases
both variable it's increase, and
or
zero there is no relationship
yeah,
between two
okay,
variables.
excellent. So let me repeat. One means that if one variable is increasing, the other variable will also be increasing. Okay, or if one variable is decreasing, the other will also be decreasing. So they have same things. Okay, -1 means if one is increasing, the other is decreasing. Okay, what can that be an example? Can you in real life, can we have an example of correlation, positive or negative? So one is positive, -1 is negative. Yes, Siham. Yes.
For example, if we take a random, if we take survey between, if we want to know there is a relationship between the weight for the father and the son, if
Mm-hmm.
or for the tall, for example,
Mm-hmm. Yeah.
and then after we calculate the correlation, if the result, for example, was +1, that means there is a relationship. If the father was tall, the son also have tall.
Mm-hmm. Actually, yes. So if the relation is 1, it means that if the son is tall, father will also be tall. If it is -1, it means that whenever the father is tall,
And
the
it's
son will be
not
short. For example, it will be opposite.
specifically value
Mm-hmm.
just one exactly, maybe 0.9. That's mean it's a strong relationship. If it was 0.5, that medium, for, like this.
Medium. Yes, excellent. Thank you very much. Okay, so let me explain as another example. Let's say we have weight with the calories intake. So if you have more calories intake, you will have more weight, for example. Okay, if you take less calories, you will have less weight increase, for example. Let's say, okay, so the relation is what we call it normally in physics, we call it directly proportional. If you increase one, the other will also increase. Okay, let's see what we have in this case. So I have the correlation matrix for the whole, all the marks. Okay, and what I see is that on the diagonal it is always 1. Why? because in diagonal means it is the relationship between Q1 and Q1, the same. So of course this is the same variable, so all the values, like here, this is between Q4 and Q4, so this is always 1. So on the diagonal we always have 1. Now we want to see is there any negative correlation? Well, we don't see anything negative because these are marks. So increase in 1 marks also have, yes, 1 is negative. That's interesting. What does that mean? Okay, it is between the project and homework 3. Well, it is by chance because this is very, very small. It's almost 0. Okay, so this is negligible. 0 means we don't have any relation actually. Okay, so some students, they had good marks in project, they had bad marks in homework. Some they had bad marks in project, they had good marks in homework. So there was no relation at all. Okay, similarly, strong relation is this one, for example. You see, okay, it's between total and midterm. What does it mean? It means that if you have good marks in midterm, you have good marks in the total. Okay, your grade was good. So midterm was the best, even this one. What is that? Homework 2, actually. You see, this is very interesting, that if you had good marks in homework 2, then that was a good predictor for your total. What about final term? This was also excellent. This was the best, actually, even better than homework 2. Okay, 91%. So if you did very well in the final term, you did very well in the total or in the final grade. The project, okay, it did not have very good correlation. Okay, what else we can see? Some interesting things. Okay, so this one is also negative between the project and homework, very small. Oh, well, it's the same thing because this row and this column here, it's the same thing. They are on the opposite sides of the diagonal. Okay, so the project and this quiz 1 has no relation. Usually the project has very small relation because the project marks were assigned using some criteria which were different than the students. Okay, so you understand correlation. We will see this with some other data, okay, to actually understand it better. Okay, then there are topics about duplicates. How do you remove duplicates and how do you find duplicates, for example? Then there is merging, concatenating, okay, and pivot tables. Now these duplicates is an easy topic, but this data set was not good for duplicates because I think there were no duplicates except for, if all students had 0, there would duplicate. We can drop that, but it's easy. We'll see that later in some other data set. And merging, this is related to SQL. So when we study SQL, we will come back to these last few topics. Okay.